Okay, so basically first I'll give you the description of your task 4. Okay, so the description is this is your exploratory data analysis task. Okay, and the description is this task involves performing exploratory data analysis on a data set, and your responsibility is to create visualizations to understand the distribution of variables, okay, and identify outliers, which we already did in the previous task. Then check for correlation between variables. Okay, so this is your task 4. So now I'm going to share my screen. Okay, so here is my Jupyter code. Okay, so for this task, first of all you have to import all the necessary libraries into your Jupyter notebook. Okay, so first is here import pandas as PD. Panda library is a basic library that we have to import for the basics functions. Then comes the numpy library. So numpy library we have to import for handling our numeric data types. Okay, then comes the matplotlib.pyplot library. So this we have to import for our plotting purpose, for plotting different kinds of bars and plots. Then comes the seaborn library. So this we have to import for the advanced visualizations. Okay, and there is like a number of advanced plot in this, like count plot, disk plot, scatter plot. Okay, then comes from datetime import datetime. Okay, so this we have to import because there are some datetime format in our data set. See, this is our datetime format. Okay, but this is not in the proper format, so we have to change this in the proper datetime format. So there is a inbuilt proper format for the datetime, so we have to import this library first. Then we have to change the list column to our datetime format. Okay, so first your task is to import all the necessary libraries to your Jupyter notebook. Okay, now your second task is to load a CSV file into your Jupyter notebook. Okay, so you all know how to load a CSV file. You have to make a variable here, then equals to pd.read underscore CSV. This function you have to use, and inside the parentheses and the inverted commas, you have to copy the location and title of your data set. Okay, so now your another task is you have to first analyze the variables. Okay, analyze our columns. So for this you have to use head function. Head function will show you the top 5 rows of your data set. Okay, so this is your top 5 rows of your data set. So here are the columns it containing, which is video underscore id, trending underscore date, title, channel title, category id, publish time, tag, views, likes, dislikes. So from this data set we are getting the clear vision that our data set is of US YouTube videos. Okay, so this data set is of US YouTube videos. Okay, so this is a data set, basically top 5 rows of our data set. Now here we are using the another function, which is df.shape. So basically this shape function will tell you how many total rows and total columns are there in our data set. Okay, so total 40949 rows and 16 columns are there in our data set. Okay, now comes the another function, which is df.drop underscore duplicates. So this function will drop the duplicate rows from your data set. Okay, so after dropping the duplicate rows, here our shape is 40901 and columns are same. Okay, so you see the difference. Before it was 40949 and now it is 40901, means duplicate rows is deleted from our data set. Okay, so this you have to do for cleaning your data set. Now here is describe function. This is for the descriptive statistics, or this is for showing the descriptive statistics of your data set. Okay, so these are the descriptive statistics, which is count, mean, estimated, min. So it will show you only of the numeric data type. Okay, integer data type. So these are the descriptive statistics of your data set. Now another function which is info function. So info function will tell you the concise summary of your data set. Okay, that how many nonal counts are there and what is the data type of each column. So nonal counts are 40901 and data type is object of the video underscore id column. Category underscore id is integer type and comments under disable is boolean type. Okay, so this is your concise summary. So till here we have first import the libraries, necessary libraries, then we have load the CSV file into our Jupyter notebook, then we use some of the function for analyzing our variables. Okay, now what we are doing, we are removing these two columns, which is thumbnail link and description. First of all, see these two columns, thumbnail link and description column. Okay, so this here is thumbnail link and this is your description column. So these columns are containing links values. Okay, so this is not apt for the visualization, so we have to remove these two columns from here. Okay, from our data set. So for removing, here we have assigned the variable which is column underscore to underscore remove. Inside that we have called our two columns. Okay, like this. Then we have to use drop function for removing the column. So here we call our variable name. Okay, so this is how our two columns are deleted from our data set. Okay, now this is your info function. Here you will see there is no thumbnail link and description column are there. Okay, here is now 30, total are 13 column. Okay, yes. So now our next work is for changing our date time into the proper date time format. So for it we are we have to import datetime library. Okay, then this is the formula, this is the syntax for it. Okay, so we are changing the trending date column. Okay, then we have to call it, then we have to call the trending underscore date column here. Okay, then equals to df, then we have to call it again and we are applying the this formula. Okay, this function. So the syntax goes like this: dot apply lambda x lambda function and datetime dot datetime dot strip time, this function you have to use, then x comma percent y, this is your year, percent d, this is your day, dot percent m, this is your month. Okay, so this is the proper syntax. So for showing the result, here is the head 3 means top 3 rows of our data set. So your training date column is now this. Okay, now this is in the proper format. Now visualization can be done. Okay, so this is the proper format. Now this is the second method for changing your column to the date time column, date time format. Okay, now we are changing the publish underscore time column, this publish underscore time column into the proper date time format. Okay, so we have to call that publish underscore time column, then we have to use pd dot to underscore datetime function, then inside the parenthesis you have to use df, then inside the square brackets you have to call again the column name, which is publish underscore time. Okay, so now for showing the result, after showing the result, here is your result. Now publish underscore time is in the proper syntax now. Okay, so these two columns, trending underscore date and publish underscore time, is in proper format. Okay, now what we are doing, we are making the three new columns now. Okay, so for making the new columns, here is your syntax. First of all you have to mention the new column name. So here I'm taking the publish underscore month because this column I want to create. Okay, in our data set, created data set. So publish underscore month equals df, we are fetching the this column value, we are fetching from the publish underscore time column. Okay, means this month value, publish underscore month, this new column value we are fetching from the this column which is publish underscore time. Okay, so for this equals df publish underscore time, we have to call this column, then we have to use dot dt dot month. Okay, dot datetime dot month, it means that publish underscore time month will be copied to our publish underscore month column. Okay, so now this is how you can fill your new column values. Okay, now second column I want to create, which is publish underscore date. Similarly this you have to use dot dt dot date, then third is publish underscore hour, and for this we have to use .dt.r. Okay, means month, day, hour values will be fetched from the publish underscore time column. Okay, now we'll see the result whether our three new columns are created or not. See, this is created. So publish underscore month value is 11 here. See, month is 11 here. Day is 13, day is 13, and hour is 17. Hour is 17 here. Okay. So it is fetched from the publish underscore time column. So these are the new columns. We have created this because we need later. Okay, in our visualization. So this is how you can create any new columns. Okay, it depends on your questions. So now here I am printing the unique sorted category underscore ID in the unique sequence. Okay, so this is your sorted category ID. Okay, so with the help of our category ID, I am going to make another new column which is category underscore name. Okay, so here I am creating another new column which is category underscore name and equals to np.nan. I am doing here, I'll tell you later. So means if our category ID is 1, then our category name will be filmed and animation. If our category ID is 2, then our category underscore name will be autos and vehicles. Okay, and if our category ID is 10, then our category name will be music. Okay, so okay, so this is how this will tell you that if your category ID is these, so then your category name will be this. So this is how all the category IDs are fixed with the category name. Okay, it means you can create a new column by using the previous created column. Okay, so this is how you can create your new column by using the previous created column. Okay, so if your category ID is another irrespective of these ID, then your value in the category underscore name will be null value. Okay, so for this we have user here np.net. Okay, so this is how you can create a new column by using any previous created column. Okay, so now we'll see the result whether our category underscore name column is created or not. See, this is created. So here category underscore name is people and blogs. So people and blog is at which ID? See here category ID is 22. So now we'll see that its category ID is 22 or not. See, its category ID is 20. Okay, so this is how you can create a new column by using the created column. Okay, yes. So now the visualization comes. Okay, so till here what we have there, yes, we have analyzed our data set. Okay, then we change into the proper data in format. Okay, these two column which is trending underscore date and publish underscore time. Then we have make the new columns. We have set the new columns. Okay, here is the syntax. You can fetch from the already created column, and this is for by using the created column you can name a new column values. Okay, so now our visualization will start from here. So here I'm using the year column. So here year column, you know how to fetch. Here I'm again fetching from the publish underscore time by using the .tt.year. Okay, so here the question is to show the total published video per year. Okay, so for it we have to choose the two column which is year first, then second will be your video. Okay, so these two column we have to take. So here first of all you have to create a variable name. Okay, here I have taken the yearly underscore count. Then you have to group by the this two columns. Okay, which is year and video underscore id. First video underscore id dot count. This count function will count the values of the video underscore id. Then it will group this video underscore id column with the year column. Okay, so after grouping this your answer will be here. Okay, now we'll create a bar chart for the this variable. Okay, here we have to use dot plot function. Kind as bar, you know how to plot a bar chart. Okay, kind as bar, x label and y label you know how to set, and title. Okay, so plt dot show is for showing the chart. So this is our bar chart which is showing total published video per year. Okay, and here x-axis is year and y-axis is total published count. So here you will see only 2017 and 2018 year is showing the result. It means our data set is containing only these 2 years values. Okay, now comes the second visualization, which is total views per year. Okay, so for checking this total views per year, we have to group views column and year columns now. Okay, so views dot sum. First, this sum function will sum the values for of the views. Okay, then it will group by this year column. Okay, then you have to create a bar chart. These all are the syntaxes are same. Here it is plt dot xdix rotation equals 0. So but this means here rotation equals 0 degree means your x-axis are in the same plane. These are in the same plane. Okay, and if your rotation, see here rotation is equal to 9 degree, so 90 degrees, so your x axis values are in the 90 degree. So it is basically the rotation of your x-axis. Okay, so you have to use this function for it. Here x-axis rotation 45 degree, so here your x values are in 45 degree. Okay, so this is your x-axis. Okay, then yes, and here is the another new function which is plt dot tight underscore layout. So basically this function will check that your plot or graph should be proper, not it should be not overlap with each other, and should be in the proper syntax and visually appealing, and should be tight layout of your plot and graph. Okay, so this function will check this, and plt dot show is for showing the result. So this is the total views per year bar chart. Okay, now comes the another, which is for top 5 categories. You have to use category underscore name, and you have to group by this by the views column. So here it will first sum the views column, then dot reset underscore index. So basically this reset underscore index function is used to reset the index of a data frame. Okay, like when we perform operations, the index can sometimes become unorganized or contain some gaps. Okay, so this function basically help us to reorganize the index. Okay, so first some function will sum the views, then after summing the values of the views, it will set in the index. Okay, then it will group by the category underscore name column. So here for this, for seeing the top 5 categories, we have to sort the category by views in descending order. Okay, so here you have to make a new variable, then category underscore views. This variable you have to use, then dot sort underscore values, and by views ascending is false because we want in the descending order. Then here comes the dot head 5. It means it will show you top 5 categories. Okay, that's all are the syntaxes are same for bar chart, or you can say bar plot. So this is your top 5 categories bar plot. Okay, now comes another plot, which is video count by category. So here we have taken the count plot. Okay, so count plot is the part of the Seaborn library. So basically count plot is a type of visualization that displays the count of observation in each category. Okay, it's like a bar chart. It show you the charts in the rectangular bar. Okay, but it shows the frequency or count of different categories. Okay, it is helpful for quickly understanding the distribution. Okay, so this is your count plot, which is the part of the Seaborn library. So here figure size we have fixed is 12,6. Okay, length and breadth. Here x we have taken the category underscore name column. Data is df. Order is our category underscore name dot value underscore count dot index. Means it will first calculate the value of the category underscore name, then it will set in the indexes. Okay, this index function. Rest all are the same syntaxes. So this is your video count by category count plot. Okay, so this is your count plot. Now comes another, which is number of videos published per hour. Okay, so here we have to take the publish underscore R column, okay, this a new column that we already created, okay. So this you have to use dot value underscore count will count the value of this column, then it will sort in the indexes, okay. Rest all other syntaxes are same. Here's the difference is just this, which is palette equal rocket we have set. So basically this rocket library, this is in the Seaborn, okay. So basically it refers to a specific color palette, okay. It will typically consist of a range of vibrant and contrasting color, which can make your plot visually appealing and easier to interpret, okay. So by using this rocket palette, here is your result, which is this. It is a contrasting color, okay. So it is very visually appealing, okay. So this is because of this palette equal rocket. Rest all other syntaxes are same. So this is your bar plot for showing the number of videos published per hour, okay. And here x-axis is hour of day and y-axis we have set as number of videos, okay. Now this is your line plot, okay. This is your seaborn line plot basically. So we have to group by the publish underscore date column with and here we are using the dot size function. So basically this dot size function is used to determine the number of elements in a data frame, okay. So yes, so here we have fixed the size of a figure, which is 12,6 length breadth, and for line plot we have to use line plot function, and data we have use, which is this video underscore count by underscore date, this, okay. And this is for title x y label. Rest all other syntaxes are same, okay. So this is your videos published over time line plot, okay. And here x-axis is published date and y-axis is number of videos, okay. Now comes, this is your seaborn scatter plot. Now this is your seaborn scatter plot between views and likes column, okay. So for it, you all know you have to use scatter plot function. Here we have used the data equal df, and x is views and y is likes. So this is view versus like scatter plot, okay. Now comes the last plot, which is here we have fixed the size of this plot, which is 14,8, and here we have used plt dot subplot underscore adjust, okay. So basically subplot underscore adjust, but this function is used to adjust the spacing between subplots in a figure, okay. Like when you create a figure with multiple subplots, okay, there might be unwanted gaps or overlaps between them. So function this subplot underscore adjust function allow you to fine tune the spacing by adjusting the parameter, okay. And in this, here w space and h space are parameters to control the horizontal and the vertical spacing, okay. And as for the top parameter, this is the top parameter. It specifies the position of the top edge of a subplot, okay. And your plt subplot is 2 comma 2 comma 1, and this is your count plot basically. So first count plot is title is comments disabled and its font size is fixed 16. Second count plot is your rating disabled, okay. And similarly this is your third count plot, which is video error or remove, okay. Now comes the last part, which is the correlation. So basically, first correlation in data analysis refers to the statistical relationship between two or more variables. Okay. Basically, it helps you to understand how changes in one variable are related to changes in another variable. Okay. So for this, we have to use dot co function, and this is the correlation value of the views and likes. So you can create any correlation between any two columns, okay. It should be integer data type column, okay. So this is your correlation of the views versus likes column, okay. So yes, this was all your task 4, which is exploratory data analysis. First, I am going to give you brief once again, okay. So first of all, you have to import all the necessary libraries, then you have to load a csv file into it, then you have to use some of the function for analyzing your variable, okay. Then you have to change your date column into the proper date time format column, Okay, this is how you can change. This is the two methods for changing into date time format. Then if you want, then you can make a new column if you want in your visualization. And if your question is depending on the creation of the new columns, then you can create new columns by using created column. Okay, this is how. And this is your another new column which we created by using the category underscore id column. Then from here our visualization will start. Okay, and start. So this is your first, which is total published video per year. So in this you have to group by the video and year column, and rest all syntaxes are same, which is for setting the x y label title and for showing the result. So this is how you have to visualize your questions. Okay, after analyzing your variables, then you have to visualize your variables like this. Okay, by solving the question. Then last comes the correlation part. So I hope this is clear.